of inertia about their own axis. Their thicknesses are also same. If the ratio of their material densities is 16:1, find the ratio of their radii. Find the ratio of their radii. So here generally we need to consider the moment of inertia. What is the moment of inertia formula? I is equal to mr square. I is equal to mass is equal to what's the formula? Density into volume. Mass is equal to what's the formula? Density into volume. Then I is equal to density into volume is nothing but again what's the formula of volume? And that is nothing but area into thickness. Thickness of that uh, disk r square. Then I is equal to disk is in the circular shape. So area is equal to pi r square into t into r square. Now I is equal to rho pi t r square into r square r power 4. Okay. So here I am taking that their thicknesses are also same. They mentioned thicknesses are also same. Nothing but t same. Density same. Pi also same. Then what about that? I is directly proportional to r power 4. I is directly proportional to r power 4. Then I1 by I2. I1 by I2 is equal to R2 by R1 whole to the power of 4. I1 by I2 is equal to R2 by R1 whole to the power of 4. Then I1 by I2 is equal to so here what is the ratio of material densities? Material densities is 16 is to 1. Same moment of inertia. Moment of inertia also same. So I is constant. I proportional to R power 4. Material densities. Here we need to consider rho. Rho is not same here. I is same. So I is same. This formula can be written as I1 by I2 is equal to R1 by R2 whole to the power of 4 into rho 1 by rho 2 into rho 1 by rho 2. Both are same. Moment of inertia same. So I1, I2 get cancelled. Why? Because moment of inertia same. I is equal to same. Now 1 is equal to R1 by R2 whole to the power of 4 is into rho 1 by rho 2. I required R1 by R2. And that's why send this rho 1 by rho 2 this side. Cross multiplication. Rho 2 by rho 1 is equal to R1 by R2 whole to the power of 4. Then R1 by R2 is equal to R1 by R2 is equal to here whole power 4. If you take this side 1 by 4, that is rho 2 by rho 1 whole to the power of 1 by 4. Whole to the power of 1 by 4. That implies R1 by R2 is equal rho 1 by rho 2. Rho in the problem given that rho 1 by rho 2 is equal to 16 by 1. 16 by 1. Now I require rho 2 by rho 1 here. Rho 2 by rho 1 means reverse the term. 1 by 16 whole to the power of 1 by 4. 1 by 4. 16, 2 power 4. 4, 4 get cancelled. That is equal to what's the value? 1 by 2. And this is the answer. Ratio of radii of the two discs. Okay. And then see this formula. See this problem of first. Find the moment of inertia of the center of mass m, radius r, and of central angle theta radians. Central angle theta radians. Moment of inertia of the sector of mass m. This sector consisting of mass is m. Only this part. Mass is m. Okay. So now with that, here we are taking the concept as how come we consider that total 2 pi radian. 2 pi radian is nothing but 2 pi radian is nothing but for small angle theta. Like that, n times has to be considered. N into theta. Then theta is equal to what's the value? 2 pi by n. 2 pi by n. Like this, thetas are n times n into theta. For example, this angle is 1 degree. Total nothing but 360. 2 pi radian is nothing but 360. So this 1 degree has to be multiplied with the n. Then theta is equal to what's the value? 2 pi by n. And now here we are taking that moment of inertia of the small disk. Like this, n parts we have. N parts we have. Total disk is I disk. This is the total moment of inertia of the entire disk. In that, how much part? The entire disk is divided into n parts. Each part having moment of inertia nothing but by n. Total moment of inertia is this one. I require the small moment of inertia. Like the small moment of inertia are how many? Like the small parts are how many? N parts. So total moment of inertia by n. Then you will get the moment of inertia of the small part. Then I disk. I disk is equal to, this is nothing but what's the formula of disk? Half nothing but mr square by 2. You know well, mr square by 2. The moment of inertia of the circular disk about an axis passing through the center and perpendicular to the plane is nothing but mr square by 2. Okay, so this is one small part. Like that, how many parts are there? N parts we have. So I is equal to. How come we consider that? M n parts by, in the denominator already we have n. So n will get cancelled. Then what's the value? Mr square by 2. That is equal to what's the value? Half mr square. Very simple. This is one part. Like this, how many parts are there? N parts are there in the disk. I is equal to, I means what? Moment of inertia of the small part. That is I. Total moment of inertia by n parts. That is equal to moment of inertia of the disk mr square by 2. Like that, how many parts are there? N parts. Then only you will get the total moment of inertia. Then already in the problem, in the formula, we have n by n. N get cancelled, then you will get mr square by 2. That is nothing but half mr square. Okay, and then find the moment of inertia of a sector cut from a disk of mass m. Previously, some part having the mass is m. Now the total mass is nothing but what's the value? Capital M. Total disk mass. Total disk mass is capital M. Now, in this case, what is the moment of inertia of this sector which is cut from the disk? So, for example, this is the sector. What is the moment of inertia of this sector? We need to calculate. The total moment of inertia is capital M. I need to calculate the moment of inertia of this small part. Then I is equal to mr square by 2 into what's the value? Theta by 2 pi. Theta by 2 pi. Here, theta is nothing but angle here. Angle at the center. Okay.